I'm talking to Oskar Dudycz today, and I hope I'm saying that correctly because Oskar is from Poland. He's a developer advocate at Event Store, so we're working together.
Mhm.
And he's also a maintainer of a Martin library, a document and event sourced based library.
Mhm.
Uh, and today we're going to talk about some of the concepts and misconceptions of CQRS, Command Query Responsibility Separation. Um, I don't know if you want to say anything else about yourself before we dive into the topic.
Uh, I think that your introduction was right, even pronunciation. Luckily, my name, luckily my name is not typical Polish name. My brother has typical Polish name, which sounds like a snake name, so Przemysław.
Oh.
uh, so that's opposite because I think that's one of the hardest to pronounce. So, but myself, before joining Event Store, uh, I was working for over 13 years as a developer, technical lead, and architect. And yeah, in the last few years, I think that my main interest is building systems that does what business wants them to do. And I believe that event sourcing can help on that. At least that's my leitmotif. And yeah, that's also the reason why I joined Event Store DB, because that's a great chance uh, to spread the good word about event sourcing.
Yeah,
So
yeah. And when you look at the history of it, actually, Greg Young first introduced CQRS and then event sourcing for
yeah,
probably some strategic reason that you need CQRS to help you build event sourcing event source solution. But let's be honest, CQRS is not constrained to event sourcing. You can build CQRS with any kind of storage strategy.
yeah, I fully agree. And I'm always saying that CQRS is event sourcing, and event sourcing are like tequila with lemon, so they go pretty well together, but you don't need to take them together at one time. So for me, CQRS it's a much lighter pattern. By lighter, I mean that you don't need to invest at all, and it's quite simple concept. Mm, but surprisingly, I'm hearing quite often that people don't want to use CQRS because it's complex or even complicated. And I think that one of the reasons was that what you mentioned. So it's quite often conflated with other patterns like event sourcing, event-driven architecture at all. So it does not help to spread the CQRS. And
Mm-mm.
yeah, and CQRS is just like a simple pattern. It's all about segregating your application behavior. So splitting your actions, operations in your systems to command handling and to query handling. So so command is an intent to do something, to change the state, and query is a request to get some business data. What's more, quite often it's think that you need to split those two models. So it's always or quite often explained that you have write model and read model, and they need to be like totally different. They don't have to in CQRS, because CQRS, if someone reads the Greg article, not just takes the pictures or mm, some sentences from them, then it's not about the storage. It's about the behavior of the system. So it's perfectly fine, at least from my perspective, to do CQRS using even the same table for for command handling and query handling. I mean, it's aligned with what CQRS is. So command should store something or update something. It doesn't mean that it cannot read any data, because like typical pattern for updating the state is that you load the current state, then you run the business logic, and then you store new state. So, you always or almost always needs to read something. So of course you have to keep the reads as small as possible. Uh, we will probably get to that. But, I'm trying to usually be pragmatic and explain CQRS like that. So CQRS is perfectly fine to even use for CRUD applications. It's not needed to use even sourcing or other related patterns.
Yeah,
Of course,
I've
it can help, but you don't have to if you don't want to.
yeah, I've seen perfectly beautiful applications based on relational database that just had some a bit more complex state loading for on the command side, but the query side would just materialized views of views and stuff like that. So there was already a separation, and people were like, "Hey, we should turn that into CQRS," and I was like, "Oh, but it's already like that. Don't worry, you're good. You're doing good. You're doing great."
Yeah,
Um, um, I guess what people don't understand in that case, it's more like if you take the relational part, um, is that it's probably what you need to effectively make sure your business logic and invariants are enforced. It's not the same information that you need to show on the screen for a user or to send to BI or to do more reporting kind of stuff.
mm-hmm,
I guess that's the main thing that people should understand there. There is data that is needed for taking action, and there's data that's needed for that a user can take some action.
mm-hmm. I think that the easiest example of that would be that, for example, if we have um, inventory in warehouse dashboard, then normally you see there like a product names, product numbers, and how many items do you have currently in stock. So you won't be probably storing together product and availability. I expect that you will have, like traditionally, a table for products where you register all the products that you ever had in, or you have currently in your warehouse, and then you have usually a separate table to just keep the number of currently available products. And then on the dashboard, you need to join those tables together, right? So this invariant that you mentioned, you will have different invariants for products. For example, that you cannot add product with the same product number or SKU. And for availability, you might, for example, have a requirement that you cannot go below 0. So those will be separate comments, but then you can have a joint view, which is different than your right model. So CQRS enables that, but it's still possible to keep them in a relational manner, and just, for example, use, as you mentioned, materialized view, or just regular tables view, or even you can use your beloved ORM to just create a joint query, right? So
Yeah,
it's I think that what's the most important in CQRS is that it doesn't give a lot of accidental complexity if you don't try to implement all patterns at once. So you can, even if you have CRUD application, then it can quickly appear that it's not so CRUD anymore after a few months. And then you can fine tune your specific comments or specific queries. Like, for example, it might appear that you would like to have a full text search on your products. And for example, you would love to have more wages, so priority on product SKU and type and name, but not on the description, and you would like to use Elasticsearch. So then if you have a separate query, then you can do it, and you don't need to change the whole application. You can
Yep.
just fine tune what you need.
Yeah, and on both sides, because that the sample you just gave is on the mostly on the read side, but also on the command side. The thing is, I've had application where it was difficult to add new functionality to the existing code base because of the change needed in the ORM, and just having like, okay, we're going to add commands, a command handler, which will only change exactly what is needed with a simpler ORM or RM model behind the scene. Was so we didn't change anything in the existing system. We added stuff, and that's one of the benefits as well. I think it's that you have a separation of all operations that you have, and more control over them. And it's the easiest way for me to delete some operations when they're not needed anymore. It's like simple. I'm deleting a bunch of files and it's done. But you mentioned that the query should be simple, or the command side, or the data you want to load should be simple, or can be simple.
Yeah, simple is a hard word. It's hard to define what's simple. For me, it might be the one thing. For the other, it might be different thing. But yeah, in general, there shouldn't be much business logic on the query side. We could even say no business logic, but some mapping if you need to do it, then it's some kind of business logic. But I don't think like you should be doing a lot of mapping. Probably for me, what's good to have on query side is if you are querying, then like filtering, that's obvious thing. And maybe like a limiting, so getting a subset of all the fields. For example, if you are getting query for list of products, then you might not need all the information like description or notes, etc. So if you have backing table that have much more columns, then yeah, it's fine to limit the subset or do a join to add some. But yeah, the less the better. And the I think that we should try to keep our also data model, so storage model, that will be aligned with our query. So for me, the ideal state is that I can just query the specific source. It might be table, it might be collection of documents, it might be blob storage, PDF, whatever. But I can just query this specific data storage model and just apply some filtering on that without needing to map anything or join, because then I can have a better performance. So that's the ideal state for me. I don't know, what do you think?
Um, might be a bit different. I might compose data from different stores in some cases when needed. But I do agree that having on the query side and on both sides actually, really focused um, handling is the best way to go about it, and this is because it makes it future proof. I mean, if you take the typical line of business application, you have like list details page, and you have thousands of those kind of thing, and what I typically see is that people are using exactly the same query for the list, which is a subset of the data that is shown in the details. And they use the same query, and that list takes forever to load. And when at least when from the moment you have like, okay, I'm doing the correct select or the correct projection, if we talk in event sourcing term, or just the correct collection in your document database. It simplifies stuff, and you can make you can make adjustments where performance matters. So it's more targeted, and you can think in isolation for each of those cases. Okay, here I need some kind of performance, or need to get some trick up my sleeve. I can apply it to there, and I know that it's never going to have an impact, or as low an impact as possible on the rest of the system.
Yeah.
And especially when using ORMs, and the same mapping, ORM mapping on the command side and on the query side, where you add functionality and then your query side breaks, or you need things on your query side and then your commanding side breaks because you use exactly the same object model if you're into object-oriented world, and that is fails short when things get more and more complex and new functionalities are added.
Yeah, I fully agree. The thing that for me it's also a benefit of CQRS is reducing the cognitive load and context switching while coding. So when you are working on the command handling, then you are focusing on how to store the data, how to make the business rules applicable properly, and then you think how to create read model that will be fine-tuned, and you can start with the right model, and then you can afterwards you can focus on queries, especially if you are using event sourcing, because then you have already all the data that's needed in events, and you can read events and apply them. But even in the regular approach, like traditional relational or document-based approach, it's also highly beneficial, and it helps in creating loosely coupled functionalities. As you mentioned, if you are using ORMs or you are using traditional layered architecture, like clean code architecture. So I'm usually calling the clean code onion architecture, not only because of layers. uh, because then if you are changing something in the single layer, then you need to, then that change needs to be reflected and will be immediately reflected on all the functionalities. So risk of change is extremely high. So sometimes you just making one liner that will, together with unit tests or automated tests, will take you just like at worst half of a day, but then you need to schedule like 3 days of regression testing to make sure that you can apply that. And that quite often leads to just omitting that change because you don't want to take that risk. And if you have the CQRS, then you have slices like that. And if you don't make them like extremely generic, then, or even if you have them generic, then you can still just take the generic part out of the single slice and just apply the logic, the totally separate logic.
Yep.
Because the command pattern is directly taken from the transaction script. It's an evolution of the transaction script. So, and transaction script is just that you are coding everything in one method, which can be a good pattern or anti-pattern, depending on the how it is done. But if you like focus on the specific operation, like specific command or specific query, then you have higher chance to optimize or differentiate from the rest methods. Like you can have 95, for example, 95% of methods run with the classical ORMs, etc., CRUD based, and you can have like the most substantial 5%, which is fine-tuned and running the custom logic. So
Yep.
I think for me, this is like those two parts are really important and benefit of CQRS.
Yeah, it allows to choose. Probably with the default, you should keep for indeed most of the code base, but then you have the possibility to choose something else in another part if that's needed. Another things I've seen with CQRS, there is a big debate about how command um, and it's probably due to CQRS, which is
Mhm.
command query separation, which is something that appeared in the Eiffel language,
Mhm.
which basically says, oh, when you're mutating an object, something, you don't return anything. You need some kind of getter to get the results.
Mhm.
And this has come into CQRS land as well, saying my command cannot return anything. My command
Yeah.
returns nothing. That's kind of my opinion, not correct.
Yeah, in my opinion, it's also not correct, especially that it's really hard to define what does it mean return.
Yeah,
Like, I think that the perception about that is spoiled with the object-oriented approach. You know, C# and Java are the most popular languages, and they are mostly object-oriented. So then you can have like a void uh, return value, which means that you are not returning anything. But in some languages, it's not possible or almost not possible. Like, for example, in functional language, you should always return something. And even if we are thinking about this object-oriented languages, then like, is throwing an exception returning a result or not? Because for me, it's just an implicit result, right?
yeah, yeah. My exception meaning something that the user should do and is wrong, and
Yeah,
oh, you entered the wrong code. Exception. Um,
yeah,
that,
exactly. So even if we allow those exceptions, and we always might have them, then we always return something, right? Of course, we should try to avoid returning some business data as much as possible, but I don't mind, for example, returning some. If this command is creating a result, then returning created object ID or some status of operation. I don't mind doing that. Of course, we should try to avoid returning as much as we can, but if we are just doing that for the purity, then it doesn't make sense.
yeah, at least it should say, okay, I've done it, or no, haven't done it
Mhm.
for this and that reason. That's the minimal that could happen. Um, there's also one thing, and it's about decomposition. Command handler that. Uh, but wait, maybe you have an other misconception in your
Mhm.
list.
No, we can go ahead.
Oh yeah,
I will
um,
add later.
big commands that do way too much. That's something I've encountered as well, which are not like focused on one specific transaction or business transaction.
Mhm.
I don't know if you've ever encountered that kind of stuff, and difficult
Yeah,
to handle.
yeah. I think that there are two parts that are most complex here. I mean, besides spaghetti code, which I know, I think that we cannot stop people from doing spaghetti code. But if we are thinking about some issues that, like, real issues that someone trying to implement CQRS may face, is that it's said that normally you should only update the single record. And what does it mean? Because it's not like a rule just for the rule, but to be sure and to not block your scalability of your application, then you should try to model your domain in a way that single command will be changing the single object, because then you can do your business logic based on the data that is on this specific record. Then you can do stuff like optimistic concurrency and other stuff. Or you can, for example, take this data and put it into some blob storage or columnar storage like Dynamo or Cosmos. You can do whatever you want as long as you keep your objects separated. But if you are touching more than one object, then you need to have some kind of transaction. It can be like a database transaction. So it's extremely easy in a relational world. So it helps people to like overcome modeling issues by having those uh, transactions. But other storages are not so great on the transaction. And nowadays we are living in a distributed world, so it's way harder to have like a technical transaction. And if not, then you have to roll up your own transaction handling like Saga and process managers. So things can get more complex. Mm, so I believe that the critical part, if we want to keep that, is to try to really focus on the right modeling. And if we cannot do, then of course we sometimes need to live with some pragmatic decision, like doing requests to other table to verify, like for example, if we are reserving something, then making sure that this product is still available somewhere. But then if we decide to do that, then we have to be aware that if we read this data, then it might be stale. So even if we are using relational table and database transaction, then between we database returned a query result and we got it, then this state might change. So even in the traditional approach, we don't have that guarantee. So I think that we just need to be straight to ourselves and understand what are the consequences and what are risks. If the risks, we say that risk is low, aka famous last word,
Mm-hmm.
then we can do it. So for me, that's the one case, and the other one, which is also which is non-trivial in CQRS, is doing batch comments, like imports, etc. How to handle them. So whether, because depending on the implementation, but command handling with all the middlewares, etc., can be quite heavy. So if someone wraps command handling with a lot of middlewares, like checking permissions, doing some logging, putting some metrics, and whatever, then spanning up like a 10 comments instead of single batch might be costful. So then people try to do it in the single batch. And for me, it might be also fine because CQRS allows us to do it. So for example, write stored procedure to import the data. So do it classically. If that works for this particular business case, why not? But again, we need to understand what are our risks and what are consequences of if this risk will appear, right?
Yep. There's one thing about batching, which it has nothing to do with CQRS, this one, but batching.
Mhm.
People think the first question when people have like, oh, we need to do some batching operation. We have like 10,000 operations that needs to be done, and then they ask, oh, we want to send one command or 10,000 commands, and I'm like, and the question is always, which one is good? The first question I have is, okay, does the batch represent a business transaction, or does all rows in that CSV file represent a transaction? So
Mhm.
can one fail out of those 10,000 and be handled later? Or if this one fails, all 10,000 need to fail or not being processed for some reason? That's the number one thing to think about when doing batch or imports of stuff. Is the import the transaction, or is each individual row the a transaction?
Mhm.
On transaction on business level, not database transaction. And that helps to decide, okay, I'm going to have like one or 10,000, and just make sure that those 10,000 are done, and eventually that one, okay, will be handled by a human operator, which will correct anything that's that needs to be done.
Mm-hmm.
There's one other thing that I find interesting about CQRS. Everybody is comparing that to REST, and do I put my messages or my commands directly through to some HTTP API, or do I need a command bus, or do I need a query bus, or is it an in-memory bus? Is it a persistent queuing mechanism, and so on? So quite a few options over there.
Mm-hmm. Yeah, so when I hear that, then I'm usually asking about what's their paranoia level. So what guarantees do they want, right? Because and what's the current scale of the application, like known scale and predicted scale? Because I usually suggest people to start small and grow big, because I think that if you try to imagine what will be in the future, then probably you will fail, and you are risking that you either over-engineer something or oversimplify something. So I think that focusing on the right building blocks, and CQRS enables that, because you might fail in this single command handling, but then you can improve it, right? Because it appeared that it's not performant or it's not done properly. And then, for example, you can start with no buses. You can just call the command handler or query handler directly from code without any middleware. I like command handlers because it enabled me to do some pipeline, like I mentioned, wrap it with some middleware like logging or exception handling or permission checking. But if you don't need it, then don't use it. That would be my recommendation. So keep it stupid simple.
Yeah.
And if you need it, then, and if you don't see like if the risk of losing some data is not high, and the consequences of losing that data are even lower, then I believe that it's enough to start with some in-memory handling or in-memory buses, because they help you to just keep things simple and learn pattern before hitting other accidental complexity. Because if we use some distributed quick queuing, even the most simpler one like Zero MQ or uh, Rabbit can be quite simple in the basic usage, then it brings additional moving piece into your architecture. So if you are starting new application greenfield project, then in my opinion, it's risky to try to use those technical solutions from the first step, because you might end up fighting with accidental complexity and not thinking about your business use case, not delivering. Of course, we should predict what might happen, because if we know that, like right now, in-memory solution will work for us, but we expect, and that's the business assumption. And by assumption, I don't mean like, we would be happy to have millions of customers. Everyone would like to have them. But if we expect, and it's like a part of the project, I mean, most of the startups assume that there is some tipping point, right? When this is like then where decision happen about go, no go. So if we reach that scale, then we will continue. If not, then we are just closing that and trying new stuff. So if we know that we need to reach some scale, then yeah, it's good to not postpone those decisions and just try to do it gradually, also work on those technical matters.
Yeah, that's interesting, because again, it's CQRS, and I think we're about the time we had together, but I'm gonna make a small wrap up. It's like, CQRS that can for me enables separating. It's not about the technical stuff. It's actually because it enables me to distribute the work among the team,
Yeah.
separating the stuff. But that's also separating decision based on each use case. And for instance, what you just explained, scaling where it matters and when it matters, because that's one big misconception I see, or it's not a misconception, but a kind of oh, we need to scale, and we tend to believe we need to scale everything, while
Yeah.
probably it's like 5% that need to scale.
Mhm.
The rest doesn't need to scale, and it's quite good to have some simple code doing stuff in memory. But those 5% that matters,
Yeah.
that needs to scale, and then you can concentrate on that one and not having to support 100% of your system with more complex code, while you can have like 5% of your code base that is handled
Mhm.
by that kind of use case, that kind of complexity.
Yeah, I agree. The thing that I would add is because we didn't say that explicitly, but because many people are afraid of CQRS because of the eventual consistency. So in
Oh yeah,
general, I believe that you don't have to be afraid of eventual consistency. What's more, you need to like live with that, because in current world it's unavoidable. But if your business use case and you are using just relational table, then you don't need to have the eventual consistency. As we discussed at the beginning, it's perfectly fine to even do CQRS on the single table. It will be perfectly valid CQRS. And for me, like the eventual consistency or scalability or guarantees, it's a technical detail of implementing CQRS. Because if I really recommend to read Greg's book or article. I'm not sure whether it's, I think
the
20,
original one.
yeah, 25 pages. So because then it's like almost no, it's about storage. It's about behaviors. So uh, how do we implement CQRS? It's up to us, up to our business use case and the guarantees and scalability that we would like to achieve. So I think that I would like to just underline that CQRS, it's not about storage. It's about segregation of the application behavior. So slicing our application vertically.
That's a great conclusion.
Thank you.
Thank you, Oskar, for your time.
Thank you. Thank you.